Alright folks, today we're working on evaluating piecewise functions graphically. A few of you asked me for this video. You need some more practice on it, so here's what we're going to do. I'm going to talk about what evaluate physically means, what you should do when you see this word evaluate, and then I'm going to lead you through an example with a bunch of them, and then I want you to go finish this second one. So I'm going to pause this for a second and just let it be still, and that way you can copy this graph kind of carefully. So this graph, this point comes down to negative 2, 2. Goes all the way up to 0, 2, and then starts at 0, 0. The next point is going to be 1, negative 3, and then 2, negative 4, and then 3, negative 3, and then 4, 0, and this point is at 4, 2, and goes all the way horizontal. And then you've got a bunch of these to copy down. And again, go back, pause that where you need to, make sure you have this graph copied nicely before we start. Alright, we're doing the second one. So pause it, make sure you get everything ready. This should start at negative 5, 4, negative 4, 2, negative 3, 0, negative 2, 2, negative 1, 4. And then it's going to jump down here with an open circle at negative 1, 0, 0, negative 3, 1, negative 4, 2, negative 3, 3, 0. And we have a linear piece in the middle, so this quadratic and this linear are separate pieces that goes from 3, 0 to 4, 3, and then at 6, 3 is an open circle. But again, go back and copy that if you need it. Okay, so when we see the word evaluate, because I don't know what's happening here, I'm looking at your quizzes results, and the word evaluate is literally asking this question. It's asking, what's the output value, which by the way we know what output is, it's just the range, which is just the y, for a specific x, which is, actually let's not say x, let's say, let's use output for a specific input, which we also know is domain, which is x. So when it says evaluate, it's asking what's the range value, what's the y value for a specific domain value or a specific x. So we could say what's the output value for a specific input, we could say what's the range value for a specific domain, we could say what's the y value for a specific x input or a specific x. So if we look at this graph, we're looking at, when we say evaluate the function of the indicated values, we're saying for f of x, which is this graph that's over here, it's all funky looking because it's piecewise, that says what's the y value for a specific x value of this thing. So my x value here is negative 3. So if I have an x value of negative 1, negative 2, negative 3, what's my y value? Well, because there's nothing here, because there's nothing on that line, this does not exist. Does not exist because there's nothing there that can meet that value. So let's look at one that is going to give us an existence. So if our x is negative 1, we're asking what's the y value when we have an x of negative 1. So when I look at this graph, I find my x's at negative 1. I know there's a point right here. This is the point, negative 1, 0. So it's asking what's the y value at that point. Well, the y value is just 0. It's just the other half of that point. It's your output. If you have an input of negative 1, you get an output of 0. Alright, f is 0. Doing the same thing, only here we have two different points. So remember that when we have a closed circle, this is the equal to part, and that's not equal to, so like at negative 0.000001, it's going to be on this part, but once we hit 0, it's going to jump down to here with this equal section. This point is at 0, 0. So what's the y value when x is 0? Well, it's 0. Okay, f of 1. We're going to look at what's the y value when x is equal to 1. So 1, negative 3, which says my y value is just negative 3. F of 2, what's the y value when x is 2? So the only place on this line where x is remotely even 2 is that point right here, which is 2, negative 4. So just negative 4. Same thing for f of 4. When x is equal to 4, what's the y value? So here x is equal to 4. We've got, again, an open circle and a closed circle. We're going to pick our closed circle because it's an equal to spot. So we get input of 4, output of 0. Y value when x is equal to 5. So we go over to 5. We go, oh, this point right here, which is 5, 2. So 2 is the output. Alright, so here's what we're doing now. Take a second, given a g of x, which is just this graph below, evaluate at the given locations. So I'm doing the exact same thing, except instead of the f function, I've got a g function. So g of x, so when x changes, I just want you to tell me what the y value is when x changes. Go ahead and try these problems with this graph, and that way when you come back in a second, after you pause it, you can check to make sure that you're doing right, or you can ask me any questions that you might need to. Alright, go ahead and pause it and give it a try. Okay, g of negative 5 is going to be 4. Y value is 4. G of negative 3 is going to be 0. G of negative 1 is the closed circle, which is again at 4. Looks like we have an absolute value function over here. G of 0 is going to be negative 3. G of 2 is going to be negative 3 again. And G of 6 is going to be another does not exist because this is not equal to. If I had asked for G of 5.99999999999 falls off a cliff and comes back with 9999999 whatever, it would have totally been 3. But because it's not equal to here, because it's an open circle, this one does not exist. Alright folks, make sure you ask before you have any, if you have any extra questions that are left over, bring this paper to me to say, hey, I looked at this is the exact part I don't understand, so that I can help you very specifically. Alright folks, good luck.